Okay, everybody, let's do some contextual problems involving the sine law. So we're going to apply the sine law in some situations that are a little bit more problem solving than just sort of here's a triangle and find missing parts. Alrighty, so let's see what we can do here. The first example, this is Mary is flying her kite and the string makes an angle of 75 degrees with the ground. So let's see if we can draw a diagram for this. So we've got sort of the ground along here. And Mary's flying her kite from some point on the ground, and then we have her string going up in the air. So I guess her kite is kind of flying up in this area somewhere. So there's the string going up to the kite. And it says the string makes an angle of 75 degrees with the ground over here. And she lets out 45 meters of string. So we've got 45 meters along there like that. Okay, so when Charlie sees the kite at an angle of elevation of 60 degrees. Okay, so if Charlie sees the kite at an angle of elevation of 60 degrees, that's a little bit further away from the kite than Mary is. So over here we've got a 60-degree angle. Okay, so this is Mary here, and this one's going to be Charlie over here. So we could call this side C to correspond to angle Charlie. We could call this side M if you want to correspond to angle Mary. And it says, how far apart are Mary and Charlie? So that's going to be this distance right here that's in between them. So if we're going to use the sine law to solve this, same patterns as always. We have to have a known pair of opposites. So the 60 degrees and the 45 meters are going to do that for us. We want to get side D down here, but we don't know the angle that's opposite to it. Well, that shouldn't be a big deal. We've got 75 degrees there and 60 degrees here. So 75 plus 60. Is going to give us a grand total of 135 degrees, which makes this angle right here 180 minus 135, which I believe is going to be about 45 degrees. So we've got a 45 degree angle there. So if we set this up using the sine law, d divided by the sine of its opposite angle, which we now know to be 45 degrees, has to be equal to 45 meters divided by the sine of its angle, which is 60 degrees. Okay, so there's our sine law with its ratio set up. So all we have to do now is solve for d. So if I multiply both sides by the sine of 45 degrees, I get d equals 45 sine 45, it looks like. A couple of 45s up top there, all divided by the sine of 60 degrees. And so any good calculator will be able to tell us an answer there. So if we punch that stuff away, we've got 45 sine 45 divided by sine 60. And my handy calculator tells me it's 36.7, so I'm going to call that 36.7 meters roughly. So that's how far apart Mary and Charlie are. Okay, so there's an application using the sine law. Let's try another one. It says Dieter climbs up one side and down the other of a hill whose cross-section is approximately triangular. So we've got a hill. Oh, that's not very level, but we'll take it. So we've got a hill here that's approximately triangular. So we're going to go up one side and down the other. So he climbs up at an angle of 60 degrees. So we can call this 60 degrees right here. Dieter's going to go up this side of the hill and he's going to go down on this side of the hill over here. Okay, so on the way up he climbs 100 meters. So this one's 100 meters. It says on the way down he climbs 110 meters. So what angle does Dieter's climb make with the ground as he descends the hill? So as he's going down this way, what angle does his climb make with the ground? I guess we can call that, I don't know, angle theta or something. So if we check for sine law stuff, we've got a known pair of opposites. We've got an angle theta we don't know opposite to 100 meters, so we should be in business here. We can say that sine theta divided by its opposite side, which is 100 meters, has to be equal to the sine of 60 degrees. Divided by the length of its opposite side, which is 110 meters. So all we have to do is multiply by 100. We have sine theta is equal to 100 sine 60 divided by 110, and that'll give us a ratio real quick. So we have 100 sine 60 divided by 110, and that's 0.7873. So we now know that sine theta is equal to 0.7873, and we use the inverse sign to figure out what theta is. So that's the second function on a calculator typically, or sometimes the shift button. So 0.7873, and then the inverse sign of that gives us 51.9. I'm going to call that pretty darn tootin' close to 52 degrees. And there we have it. All right, so quick summary for that one. Down here, we're just going to remember all the same steps that we followed in solving any problem with the sine law. All right, thanks.